All right. Derivatives of trig functions. So we're going to kind of formally discover this. We did it with the limit definition. We used the limit definitions definitely to find the derivative of sine and cosine, and we needed to use that approach for sine and cosine. But we also used it for other types of trig functions. As it turned out, we didn't need to, because if we think of tangent as a quotient of two functions, then we could apply the quotient rule to come up with the derivative of tangent. All right, so low d high minus high d low over denominator squared, and away we go. So low d high cosine of x minus high d low derivative, that's funny, derivative of cosine is negative sine of x over denominator squared cosine squared x. Cosine squared x plus sine squared x. 1, exactly. 1 over cosine squared x equal to secant squared x. All right, so a little nicer. Apply the same idea with secant. We talked about this before, where the most important trig functions are sine, tangent, and secant, because the co-functions, we can get those derivatives based on our knowledge of the functions themselves. So secant's 1 over cosine. Low d high. Now you got to start thinking here. Instead of just mindlessly writing down steps, low d high, what's d high going to be? 0. So do I need to write the low d high part of it? No. So jump right to the minus high d low over denominator squared, and away we go. So sine x over cosine squared x. Now we tend to think of that as sine over cosine times 1 over cosine, or 1 over cosine times sine over cosine, either way. But every textbook in creation writes the derivative of secant as secant x times the tangent of x. All right. Now, you could figure out cotangent and cosecant with the quotient rule if you like. We don't like. We like using shortcuts, even shortcuts to shortcuts. So again, what is the derivative of cotangent? I'm sorry, yeah, derivative of cotangent, I said it right. Okay, cool. I didn't screw something up. Derivative of tangent is secant squared, so derivative of cotangent is negative cosecant squared of x. Derivative of cosecant, well, we know the derivative of secant is secant tangent, so derivative of cosecant is negative cosecant cotangent. All right, that's a pretty useful piece of information to have in mind, because it's either memorize 3 unique derivative rules, or the 3 original ones and just a fact. Co-functions have derivatives that are negative co-functions. All right, so sine has a derivative that's cosine, so cosine has a derivative that's negative sine. All right, so either add in or remove a co, and either add in or remove a negative, and you have the corresponding derivatives. It's pretty easy when you think of it that way. All right, so little textbook assignment. So that's page 140, numbers 1 to 35, every other odd. So 1, 5, 9, and so on. So don't do all the odds. Do every other odd. Right. And also just familiarize yourself with this notation, because we're going to talk about higher order derivatives and their meaning. But as far as how to find higher order derivatives, there's really nothing to it. If I want to find a second derivative, so the first derivative is what we've been working with. The second derivative is the derivative of the first derivative. So if I wanted to find the derivative of sine, I would get cosine. If I wanted to find the second derivative of sine, I would take the derivative of the cosine and get negative sine. So I'm just taking the derivative a second time, a third time, a 10th time possibly. All right, you see the notation here? We have the prime symbols, single prime, double prime, triple prime. And then after that, because the primes could start getting out of hand pretty quickly, we go with, instead of writing y to the fourth, we put the 4 in parentheses to indicate that it's not a power. It's notation implying derivatives. So if I have the nth derivative, it would be y to n in parentheses. All right, dy dx, d2y dx squared. That's a little weird because it looks like there's an inconsistency between the top and the bottom. It's like maybe there's a typo or something, but it's not. What this is saying is the second derivative of the function y per change in x per change in x. All right, so it's the rate of change of the rate of change. So 2 derivatives per change in x per change in x again, but still related to the original function y. That's why y is all by itself here. All right, and that's consistent throughout the line, or right on down the line. This one's a little less common, but you should familiarize yourself with it too, because it means the same thing. Second derivative with respect to x is the function y. College Board loves this one for some reason. They throw it on there all the time and people get jammed up. I don't know why. D stands for derivative pretty much in the entire course, so when in doubt, that's what it is. All right.